Hello, Curran here. Let's dig into a fun project about graph drawing with nodes and edges and D3 force. Someone came to me and said, I want something like this. And this is the data that it should show. This work is for a foundation, and their goal is to show their vast network. So the foundation is connected to the arts web, and within the arts web, we've got community vision, Silicon Valley Creates, and within each of these, they just want to have, 20 or so smaller unidentified nodes just to demonstrate the volume of unnamed arts entities associated with this node. So, for example, Arts Web maybe would end up as one of these big hubs, and then Community Vision would end up as one of these smaller nodes connected to the hub. And then their vision is that these smaller hubs would have a bunch of tiny, tiny nodes that don't even have names. So this is the task before us. I'm thinking, I'll do it in VizHub and just use probably D3. Oh, and by the way, the deliverable, what they are looking for, is an image at the end. So no need for advanced interaction or anything like that. So I'm going to go to VizHub, Data Visualization Platform, and then I'm going to sign in with GitHub. Entered my username and password, and I'm in. So I think what I'll do is go back to the home page and look at the most forked and start from this hello HTML example. I'll go in here, click fork this viz, and I'll start by opening the editor and setting the title to be Organization Network Graph. I know for sure we're going to need D3. So let me just pull in D3 from Unpackage, which is my go-to source. All right, we're at version 6.2. Nice. So I'll make a script tag and set the source equal to that URL that pulls in the D3 library from Unpackage. I notice the description is out of date, so I'll just clear out the README. Okay, I know it's going to be a D3 force layout. So let's check out D3 Force, the package that provides this functionality. And let's see if we can get something like this up and running, maybe with like 2 nodes to start. This looks like the opening move right here. So I'll copy that, go back to the code, and then I'll start building our JavaScript. I'll create a file called index.js, and in this file I'll paste that, but in VizHub, we can import force simulation from D3. So we don't need D3 dot, and let's say import force simulation, and by the way, control space will autocomplete from D3. And this is a variable. The documentation used var, but let's upgrade it to the more modern const. And we pass nodes into force simulation. So let's see, what should nodes be? The API reference says, all right, d3.forceSimulation creates a new simulation with the specified array of nodes. And so if I click nodes, okay, each node must be an object. What I'm really looking for is an example of the data structure. Here we go. Here's a good example. Nodes and links. Let me just copy this. So it creates 3 nodes, Alice, Bob, and Carol, and then the links have source and target. So this represents the connections between Alice and Bob. And the reason why 0 maps to Alice is because Alice is the first one in this array, and the index of this entry is 0. So 0 for Alice, 1 for Bob, 2 for Carol. All right, let's use this as our starting point. I'm just going to drop that in here and change var to const for just style. All right, so now we've got nodes defined, passing that into force simulation. But what about links? We're not even using links. How do we get the links in there? And keep in mind, our goal for right now is just to get something to show up with a force simulation. And then after that, we can add our particular data. But let's get links associated with this simulation. How do we do that? It looks like the constructor just takes nodes as input. But if I just search for links, look at this. Yes. What we need to do actually is add a force to the simulation like this. And you know what? All of these simulations look good. Okay, so I'm remembering now that force simulation it doesn't really have any forces in it. And you have to add these forces yourself. This was an API change sometime in D3. So we need to add the charge force, which I'm pretty sure spreads things out. It sort of repels things from each other. And then the link force pulls things together that have links between them. And then the center force just pulls things towards the center of the screen so it doesn't go, wandering off. So let's just grab this whole thing and drop it in here and remove this unnecessary line that we already have. At this point, I'll run prettier just to get nice indentation and formatting. Okay, so instead of D3 dot, we can import force many body from D3 and also force link like this and also force center. I'll run prettier again and we got to remove this D3 dot. Okay, now this should conceivably work, but we need to somehow display the result of this, and we can do that with D3 too. It says here the simulator starts automatically. Use simulation.on to listen for tick events as the simulation runs. So a tick event is when all the positions change a little bit. And this corresponds to animation frames, where we can re-render the graph and get that cool, bouncy kind of animation. So let's try simulation.on. I think we can just say simulation.on and pass in tick as the type, and then pass a callback function that gets invoked on each tick. So let's try that here. Simulation.on tick, and then pass in a function, and then I'll just say console.log tick. Okay, now we've got something that should actually run, but I don't think we've actually wired up this stuff yet. So in VizHub, it uses rollup to take index.js and parse this import syntax and then generate bundle.js, which is vanilla JavaScript that we need to ultimately include in our index.html. So here's what I'll do. Instead of this script right here, I'll say this script, that should be inside the body. This script has a source equal bundle.js. And we can get rid of this hello HTML. We can also get rid of the style on the body for the text, which we don't need. And let's see what happens. Does this run? If I open up the dev tools, check that out. We got 300 ticks. Okay, our goal is to render this somehow. And I think the go-to tool of choice is SVG. And we could create the SVG programmatically, or we could just drop it here in HTML and give it an ID so that we can query for it. I'll just call it container. And here we can set the width to be 960, which is the default width in VizHub, and the height to be 500, which is the default height in VizHub, inherited from blocks.org. Run prettier. Okay, so to get something, look at that, we got some scroll bars. This is always an issue. For this, we can get rid of the default margin that's there on all HTML pages by, in the CSS, saying margin is 0. And just to make sure that the scroll bars don't show up, we can say overflow hidden. And by the way, I'm hitting Shift-Enter to run this. That's why it's not automatically running. Okay, so now that we've got this container, in our JavaScript here, we can get access to that container. And for the variable name, I'll just call it SVG. And for this, we can use d3.select and then pass it that ID. But since select works with selector strings like CSS, we need to add this hash to make it catch that ID. And since we can use ES6 imports, I'm not going to say d3.select, I'm just going to import select from d3 along with all this other stuff and run prettier to get the formatting. Alright, still nothing's going to happen, but let's continue writing this code such that our nodes will be displayed. So we've got nodes here which we want to create a circle, I'm thinking, for each of these nodes. And the nodes are not going to change over time, so we can just set up that D3 selection once and then just update the X and Y inside of the tick event. So here's what I'll do. I'll say svg dot, and here comes the general update pattern. Select all, circle, and there are none at first, dot data nodes. So there's our data join, and we can say dot enter to get the enter selection, dot append circle. That will append a circle for each of our nodes, but to see it, we should specify some attributes. So we can say, I'm thinking we need to specify the radius and the XY position. So the first attribute will be R, the radius, and let's just set it to some fixed value for now, just say 30. And at this point, something should show up. Let's take a look. All right, we've got a little circle whose radius is 30 pixels. Okay, great. Now, well, actually, there's 3 circles in one spot. So what we want to do is get this as a selection. So I'll say const circles equals this thing. Now Prettier will put it on multiple lines. So now what we can do is inside of this simulation tick thing, we can say circles.attr. We're going to set the X and Y. So CX is going to be a function that takes as input one of the nodes that we pass in here as D. And then it's going to return D.X. And where does D.X come from? Because it's not on these objects here, we didn't specify X. The forces actually define X and Y on each node. So they will be populated when the simulation starts. Alright, so CX is D.X. And let's do the same thing for Y. Let's just make another line and say CY is D.Y. And let's see if this runs. Okay, it's working. Look at that. Those things moved around a little bit, but somehow it's not understanding the size of our display here. Let's see what we can do about that. I think this is one of our problems. Force center defaults to 0, 0, but we could pass in X and Y. So let's try that. That should at least get our stuff into the center. So if we pass in force center to be, well, the center X and Y, let's try defining center X and center Y as new variables. Up here I'll just say const center X equals, well, what should it equal? I mean, it should be the width over 2, and width we can get from the SVG. So actually, let's move this SVG up here so we can access it, because recall that we had set the width and height already on our SVG. See, width is 960, height is 500, and we can use that as our source of truth for the dimensions. So we can actually get out the attribute by passing only one argument. We could say svg.attr width, and that's going to come out as a string. So let's just make it a number by adding unary plus. And we can do the same for height. So we've got width and height, and now we can define center y to be height divided by 2. So now if we run this, boom, okay, we get some activity in the center. This is promising. Towards the end of all this, we can get into tweaking the forces and whatnot. But for now, I think I'll just make the circles a bit smaller so we can see that they're actually in different places. Okay, so now we need to add those links, make those links show up here. So I think I'll just use the same pattern as this for the links, and I'll just call it lines. And we can use SVG line elements, and the data will be links, which we do have defined up here. And each link is source and target as indices into the nodes array. So we can create a line element for each and every link, and then here is where it gets tricky. We can set x1, and by the way, here's an example of a well-formed line element. It has x1, y1, x2, and y2, and you have to specify the stroke for it to show up. So I'm just going to copy this as a reference, paste it right in here. So our x1 is going to take as input d, one of these links. And you know, now that I think about it, it's a bit confusing to use d everywhere. Maybe let's buck the trend and just use node for nodes and link for links. So I'll replace the d down there with node, and here I'll use link. So where should the x1 and y1 be for this link? Well, we need to use the source of the link. So yeah, let's say the line starts at the source and ends at the target. So we can say link.source. And link.source is an index of the array that is nodes. And each node has x, so we can say .x right here. So what this does is it takes the link, gets the source, which is an index into the nodes array, so that's why we would use the square brackets to access the node at that index. And then once we have the node at that index, we can just get .x on that node, just like we do down here. So now that we've got that, we can do the same for y1 and just change that to y. And now that we've got this whole thing, we can do a variant of it for x2 and y2 that uses target instead of source. And I think that should work. Last but not least, we need to set the stroke. I'll set it to be black for now. Now we don't need this reference. All right, let's see if this works. Oh, it does not work. Cannot read property x of undefined. Oh, I think I might be prematurely trying to set x and y, because this is outside of the simulation tick. We only need to really set these inside of the simulation tick. So I'll move that to be in here, and we can say lines dot attr, all this stuff. Now it runs, and we're still getting this error, cannot read property x of undefined. So let's go back to basics here and try to debug this. So my theory is this could be coming up as undefined. Why would that be? I thought link.source was the index, and indeed it is. I mean, this is 0, So nodes at index 0 should work. Let's just do some debugging and console.log. Nodes at 0. I mean, that should work. Okay, so that worked. It gave us this thing here. But we're still getting cannot read property x of undefined. That's weird. Is it coming from circles? What? It is coming from this? Wait a minute. This is what I like to call a Twilight Zone moment. Alright, let's bring this back, see if it breaks. Yeah, that's still breaking. Okay, let's try to just debug this one here. We're setting up our lines, selecting all lines, passing in links as the data. So let me just try right here running this. Okay, that reproduces the error. Let's break this into a function with multiple lines so that we can do debugging in here. So let me bring that console.log statement into here. I know that this line is causing the error. So let's start from square one, console.log link, and see if this works. And I believe that's the only console.log we've got going. Okay, this is good. What about link.source? Ooh, look at this. The D3 library has actually replaced source with the node object. Oh my gosh, I didn't realize it would do that. Okay, so it has actually mutated our objects here. So after passing it into the simulation, it's not 0. We can't expect 0. We're going to get this node object. Interesting. Okay. So we should just be able to say link.source.x, just like this. Okay, that looks good. So with this newfound knowledge, we can go back and fix our broken code. So no need to look up these nodes. I'm going to use my Vim superpowers to select this line here, all these lines at once, and get rid of that, and then get rid of that. Boom. Hey, look at that, it's working. Fantastic. All right, this is huge. This is a great place to be. You know what, I think I'll just, this is a good checkpoint, so I'm going to leave this viz as it is, and I'll say force-directed graph starter, because this by itself is pretty cool. Okay, so far we've got a force-directed starter. Now let's bring in this data and try to achieve our original goal with this crazy graph viz. I'm going to start by forking this force-directed graph starter and then renaming this to be organization graph diagram. Let's revisit the original goal. The original goal is to create something kind of like this based on this data. But the problem is this is not exactly data in the sense that you would think of it. You know, it's not a JSON file, it's not a CSV file. So our first order of business probably would be to create structured data from this using code. So what would the structure of this data look like? Well, we've got these main nodes that are bigger, and the things that are within these main nodes in the outline should be connected to these main nodes with edges. So these are essentially children of this parent. So in a sense, we're creating a graph data structure from a tree data structure that is represented roughly in this outline here. Let's start with something small. Let's start by making the Arts Web node connected to the Community Vision node, and also the Arts Web node will be connected to the Silicon Valley Creates node. So let's take this text arts web, and let's instantiate this in our code. And I think this whole thing about generating the data is going to be a whole other can of worms, and this file is already around 50 lines. So let me just go ahead and before we even get into it, I'll create a new JavaScript module just for the data stuff. I'll call it data.js, I guess. And pasting that text here, arts web. And let's go to index.js and identify the data elements of it, which is this here, nodes and links. So I'm imagining that we just move these definitions over into data.js, and then we can export these. So export nodes, export links, and then in index.js we can import nodes and links from /data. Now this should still be working, and indeed it is. Now we can focus just on the data itself. Okay, so we've got arts web. We want that to be the name of one of our nodes. So let me just take that text and replace Alice with that text. Now this node here will connect arts web to Bob. So now let's bring in some of those other aspects. In addition to the arts web aspect, we've got community vision. So we can turn Bob into community vision. And so now this thing represents the connection between arts web and community vision. I'll run prettier to get this on multiple lines. And lastly, we've got Carol. We can make Silicon Valley Creates into this node here, replacing Carol with Silicon Valley Creates. Okay, now we've changed the symbolic meaning of this stuff, in theory at least, but the structure is not right. What it should be is arts web to community vision. This one is good, but this one should be arts web to Silicon Valley Creates. So arts web, let's just look at the outline again. Arts web is the parent, the main node. So arts web is connected to this one and also connected to this one. To make that a reality, we just need to change the source on this one here from 1 to 0. Now this represents a connection from arts web to Silicon Valley Creates. But, looking at the output, you wouldn't know this. So I'm thinking now might be a good time to figure out how to display text on these nodes. That'll help us as we drive this forward for debugging purposes. So let's stop and do that. In index.js is where we can create text elements for these nodes. At this juncture, there's a number of ways we could go about it, but I'll just favor the simplest possible thing, which is just to have a bunch of text elements that are on top of these circles. One thing we could do if we wanted is make group elements, and then the group elements have the circles and the text, which we might want in the end, but let's just do something simple now, which is instead of circles, this can be text. Select all text elements, append the text, and then I believe the way to set the text content is to say .text, which is different than .attr, and then pass in node dot, what was it called? I think it was called ID. Yeah, node.id, node.id. This will just establish the text elements, but they won't be in the right spot unless we update them along with the circles in the simulation tick. So let's copy the logic for the circles and apply that to the text. Yeah, text is our variable name. And text elements don't accept CX. That's particular for circles. I don't know if it's like circle X or center X. Could be center X. But text accepts X and Y. So let's see if that shows up any text. And indeed it does. Look at that. All right, we're really getting somewhere. Okay, so from here we can go so many directions. One thing I kind of want to do is make the arts web bigger because the size variance is something that we're going to have to deal with throughout this process of generating the data. So let's just start now. But what would the size be? I mean, we could attach something to nodes. Let's call it size. But, you know, what would the size really be? It could be like the radius of the circle in pixels. Yeah, let's try that. Let's say it's going to be 50 pixels. Now, if we want to instantiate this in the graphics, we need to go to the place where we're defining the radius of the circles and make this a function of the node. So node is the input, and we can say node dot size. This will break if there's no size defined. So let's just make sure we've got size defined for all of these nodes. These will all be smaller. Let's say 10. And let's see if this runs. Okay, I think it's working. But the problem is it's all sort of bunched up in here. We need to get some more spacing around it. How can we do this with the D3 forces? Maybe we can tweak many body. Yeah, D3.force many body dot strength and theta. I don't know what exactly these mean, but it says here for strength, a positive value causes nodes to attract each other, while a negative value causes nodes to repel each other. Similar to an electrostatic charge. That's cool. So the default is a function that returns minus 30. Let's try tweaking that. Over in index.html, we've got our simulation, and here we're defining the many body force. And right in here, I think we can say dot strength. And I wonder, can we pass in a number, or does it need to be a function? I would guess we can pass in a number. Okay, this runs, and it does the same thing as before, but if we make it like 90, does it do anything? Ooh, if we make it 1,000, look at that. It's spreading things apart a little bit more. I don't know if these values are like legit, but, you know, it does what we want it to. So I'm noticing a couple things I want to correct right now, which is like the text, we can't read black on black, and the text is not centered. The text should be centered with respect to the nodes. So let's just work on that a little bit. How do we go about centering the text? I remember it is some attribute on SVG, and I always need to Google this one. If we Google SVG text align, yeah, we get text anchor and alignment baseline. Here we go. Text anchor should be set to middle. So let's do that. ATTR text anchor should be set to middle. And if I use prettier, it will replace the double quotes with single quotes. So if we run this, all right, look at that. The labels are centered, horizontally at least. What about vertically? They're a little bit too high. Let's try to center them vertically as well. And I think we can use alignment baseline for that. Yeah, let's just set alignment baseline to be middle, like this example. So what it should look like is something like this. It's almost exactly the same as this other line, but just it's alignment baseline instead of text anchor. So this should do the trick. Let's see. All right, looks decent, looks decent. But we still can't see the black on black. Let's just fix that real quick. One thing we can do there is set the color of the circle. I think I'll just make them gray for now. We can iterate later. And the way we do that is, I'm pretty sure we set the fill to be gray, like that. Gray is a named CSS color, that's why this works. Okay, and we've got this. This looks like a pretty decent starting point. Now, let's go back and continue working on the data. What are some of the next steps here? It's going to get more complex. Coming back to this outline, we've got 20 smaller unidentified nodes, and we've also got the rest of this structure. There's a fork in the road. Should we try to deal with this 20 smaller identified nodes, or should we get all of these named nodes in there? My gut feeling is that we should focus on getting maybe this section totally finished, and once we do that, it can serve as a blueprint for the others. So therefore, let's focus on introducing these 20 smaller unidentified nodes. The number 20 we can take from this document, and somewhere in here we're going to use this number 20. So far, we've been hard coding this stuff, and there's no algorithmic element to this. But I think we'd be better off with a more algorithmic approach. For example, like, we shouldn't need to think about or type these indices because they're going to be essentially automatically generated. So let's start down that road. The first thing I'm going to do is make nodes be just an array to start. That way we can push things onto nodes with nodes.push, and we can pass in these objects, and I'll do the same for these others. Okay, now we're pushing these, and it still runs. What I'm thinking is that as we push these nodes, we can have some more programmatic notion of a main node versus a child node versus maybe, we'll call it a leaf node, those 20 anonymous nodes. What I'm really getting at here is we need to find a way to automate adding these links at the correct time. So maybe I'll introduce a function called add main node, and maybe another function add child node. And what we would want to do is invoke add main node and pass in this object here. And then inside of add main node is where we would do the nodes.push, and it would accept as input this node. This object here would become node, and then that would get pushed onto there. One thing that is characteristic of main nodes is the large size. So rather than, once we have multiple main nodes, we don't want to duplicate the size all those places. So let me just move that into this logic here. We can say node.size equals 50. And this even can be a variable, a constant rather. I'll call it main node size. And this naming convention is, I like to use it for constants, like things that are just defined in one place that never change. So main node size is 50. That's the size that the main nodes get before they get pushed onto the nodes array. So now if we run this, it still does exactly the same thing. Okay, great. Next, let's think about adding the child nodes. Both of these are children of this main node. So let's say add child node and pass in this child node here, and then again for this other child node here. And the nodes.push will come inside of add child node, and I'll make this argument called child node, which we push. And again, we can define the size of this inside this function, so we don't need to duplicate it. So I'll get rid of size here, get rid of size here, and then the size on add child node should be child node size, which we can define up here to be, I don't know, 20, whatever it was, I don't remember. But once they're all in this one place, then we can tweak them later easily. Okay, so we're adding these child nodes, but there's some cleanup I gotta do. But the links are still defined here. But in any case, this should still run. Let's just double check. Oh, we got an error. Oh, I forgot to update the name here to child node. Okay, it does not seem to run. Let's see what's going on. Node is not defined. Oh, it's nodes.push. Node for add main node, but for add child node. I called this child node, and I forgot to update it over here. Okay, now it runs. So I called this child node for a reason, because that is as opposed to the parent node. So here's what I'm thinking. Instead of hard coding these links like this, we build it up programmatically. So what I'm going to do is move this definition up to the top so that we can have access to it. And I'm just going to comment these out because these are what we want to add programmatically. And we can add these programmatically in the function add child node. So what we want to do is push that onto links. So links.push this object with source and target, and the source will be the parent node, and the target will be the child node. And I'm pretty sure with the D3 library, you can actually just put the node objects as source and target. No need to use the index, although we could. But let's try it like that. If we say the target is the child node and the source is the parent node, now we need to know what the parent node should be. I'm thinking we can take this as the first argument, but where do we get parent node? Well, we can pass it in here as the first argument, parent node, and we can just define parent node right here. Parent node is this, the return value from add main node, and we can pass it in here as well. But the problem is add main node does not return anything. I don't know, we could make it return the node, or I don't know, we can just factor this out and say, okay, the parent node is this, and then we add main node, parent node. This is, in a sense, simpler. Yeah, we can just do it like this. So now if we run it, it still works. It does the same thing. All right, sweet. Okay, now we are in a position to add these 20 smaller unidentified nodes. Now, how should we approach this? We already have this function, add child node. And what we want to do is essentially add more children to this node, which is already a child of its parent. And the first step towards doing that would be extracting this so that we can reference it multiple times. I'll make a new variable here called child node. That can be this one. And then, now what we want to do is add 20 anonymous children to this child node. This line here adds this child to its parent, but let's try adding a child to the child node. So the first argument here would be the child node, and the second argument would be some anonymous node. So I'm going to copy this node definition, but I'll just make the ID anonymous, and let's see what happens. All right, look at that. Looks like a solar system diagram or something. All right, this is pretty cool. This is doing the right thing. So what we want is a bunch of these anonymous nodes connected to community vision. Oh, I'm just noticing I've got this junk we can clean up. All right, so to add more of these, we can just copy paste this line a bunch of times, and we've got more and more and more of these anonymous children, and it's working. Look at that. Okay, we're getting somewhere. One problem I see with this is that we want these anonymous nodes to be smaller, and we don't even want any text to show up here. So how could we do that? Maybe if we just, give an empty string as the text. That's probably the easiest way to accomplish the no text. And there we have it, no text. Okay, that's good. And we want them just to be a little smaller. The problem there is this line of code here, it's setting the size of the child node to be child node size. But what we want to do is make the size something else. I think I'll introduce another one of these constants for leaf node size. And that's going to be tiny, like, 5. And what we need to do now is use that somehow. When we invoke add child node, we should, maybe we can pass in the size. I mean, what if we had another argument where I could just pass in leaf node size like that? Yeah, that could work. In which case we would need to modify this function to accept another argument called size. And we still want these other invocations to function correctly. So we could make the default value of this child node size. And then we can use size here, like that. So if size is not specified, it'll get child node size, so this invocation will work because it doesn't have that argument. But if we do pass in a different value, like leaf node size, that will get assigned to size here and then used here as the size of the node. So at this point, there should be a single tiny leaf node. Let's see if it worked. Indeed it did. See, there it is. Now let's make all of these leaf node size. But, at this point, I want this to be more programmatic. We shouldn't have to be copy-pasting lines like this. So let's use an old school for loop. And I'm always cautious in VizHub because sometimes the for loops crash things with the auto run. So I'm just going to type it up in a comment. For let I equals 0, I is less than 20, I++. So this should run this chunk of code 20 times, and that chunk of code that we want to run 20 times is this chunk of code right here. So now I can get rid of these lines, and this should work. All right, look at that. That looks pretty darn cool. All right, where should we go from here? I'm noticing that all of these nodes that are connected to each other are pushed away from each other with the same force, but the force really should be different, I think, depending on what type of node they are. I mean, the child node should be pushed away from the main node, like it is here, but all of these anonymous nodes, I mean, they could be closer to this child node. Let's see, how could we do that? Somehow, maybe the links could contain some information about how strongly they should be repelled from one another. Maybe here, when we define the force link force, we may be able to specify some function which is unique to each link that determines the strength. Let's see, we had force link is what it was called. Here's the documentation. Apparently there's something about distance and strength parameters for each link. Distance sounds interesting. Ah, look at this. If distance is specified, so the default distance is 30. Strength is a whole other beast. I don't think we want to touch this. Yeah, I think distance is what we need here. And it can be specified as a number or a function. And that function is invoked for each link. Okay, great. So over here, we can specify the distance like this. And that distance is a function of the link. And let's just return 30 for now. That's the default. Let's see, if we change it to 20, what happens? Not much. Maybe our charge strength is too high. That just seems too high from the beginning. If we make the charge strength 500 and then the link distance to be like 50, okay. If we make it 10, things are closer together. We're getting somewhere, but I want it to be different for each and every link. So let's just say link dot distance. And then when we generate our data, we need to attach a distance property to each and every link that we push. So we've got add child node with source and target, and here on this object is where we need another property called distance. And this can be perhaps similarly to size, we could pass in something, or maybe it could be a function of size. Maybe let's have distance be its own thing that gets passed in. And just like size, it can have some default, like default distance. And default distance we can define up here as 30. Sounds decent. That's what the D3 default is. And now, when we add the child node for each of these anonymous nodes, we can pass in, maybe let's call it leaf node distance. And we can define leaf node distance up here to be, let's say, 10. Okay, this is doing something, I think. Maybe let's just experiment. If we set it to be larger, then they do go farther away. See that? So this whole scheme is working, and if we set it to be smaller, they do go closer. But let's say if I put this to 0, this is as close as they're gonna get, and I think that's because the many body force is pushing them apart. So we can go back and tweak the strength of the many body force, which is 500 here. And you know, I kind of want to be able to tweak this from the same spot as we're tweaking everything else. So let me just do that. I'm just going to make this a variable called many body strength. And the value of many body strength can be defined right here as minus 500. And many body strength we can import from /data along with nodes and links. And over in data.js, we can define it, and we can also export it to make it visible. Okay, this is fantastic. Now we can tweak everything in one spot. So if we make many body strength like 50, ooh, look at that. Those anonymous nodes are right on top of each other. Maybe we can increase the default distance to be like 100. Hey, look at that. It's getting closer. Leaf node distance, I mean, we can push those a little further apart. So maybe 20. Yeah, we got some variation now in that. And let's see, default distance, let's try 200. I don't know, maybe 150. Okay, we're getting somewhere. We're getting somewhere. This is looking pretty okay. The readability is a bit off, but that can be a final pass. I think what I'd like to focus on next is getting this structure working for all of our outline. Yeah, so we're still in the middle of this arts web after that, we can move on to these, but we still need to add the 20 smaller unidentified nodes to this Silicon Valley Creates child node. So let's do that in here. We are adding 20 child nodes, and we want to do this again for this child node here. So maybe what we could do is just copy this exact same pattern and just change Community Vision to Silicon Valley Creates. So let's try that. I'll just copy this entire thing, paste it here, and then change Community Vision here to Silicon Valley Creates. Now we've got this block and this block essentially copy-pasted, and let's see if that works. Ooh! Child node has already been declared. Yeah, that's the thing about const. If you use const, you're not allowed to reassign. So we can make that not break by using let instead. And then down here, we don't need to use let again, because here it's defined, it's assigned, and then here it's assigned. It's reassigned. It's reassigned, and that's what let lets you do. Okay, this is working. Hooray! Now, it is a little bit of a bad code smell, in my opinion, to have such copy-pasted logic. So let me go back to using const, and what I'm thinking is we can encapsulate this into a function so that we can just call this function again and again for each and every child node. I'll comment out this for now, and this one I will put it inside of a function. I'll call this function maybe assemble child node. Yeah, so we've got this function, and inside the body of this function we can put all of this logic just like that. I use prettier to format it. And the only thing that's going to be different is the name here, this ID. So what we can do is just accept that as an argument. And this here can be simplified with ES6 syntax. It's the same as this here. And now we can invoke this function, assemble child node, and pass in this string here, Community Vision. So now if we run it, we only get Community Vision. But now that this is set up like this, we can just invoke that same function again and pass in Silicon Valley Creates. And now we get both of these here like this. Okay, sweet! That's exactly where I wanted to end up. Now we don't have this sickening duplicated logic, and now we can go all out tackling the rest of the outline. Okay, now we are done with this part. Let's do now this part. Okay, so we're introducing another main node. Let's start there because everything else is going to be attached to that. It's called Social Impact Commons. What can we do for that? We need to invoke add main node again. And this is where I think we want to essentially copy this pattern. I'm just going to paste that text, Social Impact Commons, and then I'll copy paste this chunk and change Arts Web to Social Impact Commons. And when we run it, we get that issue about const. So this is where I think I would like to use let here. And just a pattern I like to do with let is just declare it once so that it's clear that it can be reassigned, and then assign it in multiple places like this. So now if we run this, there was another parent node. You see it sort of ends up moving off to the side because it's not connected to anything. Let me just tweak these constants to make sure that it's in view. I think we can do that by increasing many body strength. So if we make that again like minus 500, oh, that's pushing it away. So if we make it small, minus 30, things are not pushed away as much. Okay, that's what I'm after. I don't know, minus 10. Okay, now Arts Web is there on the screen. At least we can see that it's there. And actually, at this juncture, I'm wondering, should there be an edge between these two main nodes? Let's refer back to our original example. In this example that we're trying to emulate, the main nodes are all connected to one another. So now that we've got two main nodes, let's just add that connection. That will solve the problem that that thing is floating off. All right, so the way we can do this is we want to add a link between these two parent nodes. This is where it's kind of problematic that we're using the same name for both. So, you know, I think I'll just rename this to be Arts Web. I think this is fine because there's not going to be that many main nodes. We can have a variable for each. Now we can go back to using const Arts Web and then pass that in here. And now we can have another const social impact commons and add that there. But I think we might be referring to parent node down the line. Yeah, here we're using add child node parent node, but the parent node is going to be different over time. So I think what we want to do is accept parent node as an argument here, and then when we invoke this assemble child node, we should pass in Arts Web as the parent. Yeah, I think this is the way to go. Okay, now this is still running correctly, and now we are in a position to connect these two main nodes together with links. And this is the pattern that we need to follow for adding the links. So I'm just going to copy paste that, and the source will be Arts Web and the target will be Social Impact Commons. And distance needs to be something. Let's just make distance default distance for now. Okay, and that worked. Okay, great. See that? We've got Arts Web and Social Impact Commons connected. Now we are in a position to add children to Social Impact Commons. So let's do that. I feel like this is sort of cluttering things up. I'm going to move this definition to up here with all our, just to group it with all our function definitions so that we can just focus on the data itself down here. So we've got Arts Web, and within Arts Web we've got these child nodes, so I think I'll just move this to group it up there with this, because these are all sort of associated together. And then now that we introduce another main node, that's where we can add this link. And we can follow the same exact pattern of adding child nodes. And in this case, the parent will be, instead of Arts Web, it'll be Social Impact Commons. And these are not the right headings, so I'll just get rid of those. And then we can refer back to our document to get the children of Social Impact Commons. And this is going to be Theater Bay Area, so I'll use that as the first one. The second one will be East Side Arts Alliance. And there's going to be another one called Local Color. So I can just note that down here, copy paste this line, and use Local Color right here. So now, if we run this, check it out. It worked. Social Impact Commons now has these 3 children. Sweet. At this point, we have got these 2 main nodes totally done. Now we just have to add 2 more. Looks like we're about halfway done with the data side. Now let's focus on this one, Community Arts Stabilization Trust. this is a main node, just like Arts Web and Social Impact Commons are main nodes. So we can follow the same pattern as this block. So I'm just going to note down the name of it, and then I'll copy paste this entire block. But even before I copy paste, I see this as duplicated logic. So let me just make this into a function. And this is a function that connects main nodes. So I'm imagining I want to have some invocation here, like connect main nodes, and just be able to pass in Arts Web and Social Impact Commons. And source will be source, target will be target in this new function that we're going to define called connect main nodes. So in this function body is going to be all this logic, and it's going to take as input source and target. And again, due to ES6, this can be replaced with just this. This should work. I'll just move this up to where all of our other functions are defined to remove this clutter from the data-oriented section. Let's just see if this still runs. Yeah, looks good. Now, this is a nice compact chunk that we can just copy paste, and the name of it will be Community Arts Stabilization Trust instead of Social Impact Commons. And that can be the variable name too, as camel case. That's huge, so I'm just gonna rename it to CAST because we're gonna have to put this in here over and over and over. Okay, great. Now these headings are out of date, so I'm just going to delete these for now, and we can consult the document for what these should be. Okay, we've got a bunch. We've got counter pulse, put that in there. Luggage store gallery, put that in there. And I know we're going to have more than 3, so I'm going to preemptively lay out some space. We can just paste things. Next, performing arts workshop, and all of these have 20 smaller unidentified nodes. So I'll just paste that there. And the next one, 447 Minna Street, that one only has 5 smaller unidentified nodes. So I'll paste that here, and this has 5 child nodes, so I'm just thinking, how do we handle this? It's a deviation from the normal pattern. Let's just add another argument to this function, assemble child node. So let's pause here and make that work. Assemble child node can take as input a third argument, which is the number of anonymous leaf nodes. So let's check out assemble child node. We can add a third argument here. I'll call it the number of leaves. So like num leaves, like that. And by default, this can be 20. But if not, we use the value passed in, like 5. And then instead of having 20 hard-coded here, we can use num leaves. So let's see if this worked. We should see one of these with 5, but it looks like we need to go back again and tweak our settings because some stuff is going off the screen. Maybe let's even make the main nodes a bit smaller, like 40. Child nodes even can be smaller, like 15. And the default distance, maybe we can make it smaller, like 100 perhaps. Or maybe even smaller, like 30. Leaf node distance is okay. Oh, I think what it is that not all of the main nodes are connected to one another. See, we're missing a connection between Social Impact Commons and Community Arts Stabilization Trust. I think that's why they're sort of going off the screen. Let's fix that real quick. We're connecting the main nodes for each of these, but I think I want to group all of these together at the end because we need to essentially have all pairs connected. So I'm going to copy paste these, and we need to get the connection between social impact commons and CAST. Now let's check it out. Okay, this is looking better. Everything is connected, but it's still like going off the screen. Oh, one thing we could try is to just set the height of the viz. Yeah, maybe let's try making it a square. So if the height is 960, we can update our code to use a height of 960 here. Okay, look at that. Now it's a square, and everything is inside of that square. Okay, what I really was going about here is checking that 447 Minna Street actually only has 5 anonymous child nodes, and indeed it does. Indeed it does. Great, great, great. So we can keep going with the addition of data. So where were we adding the data? We were at 447 Minna Street. Let's keep going in our document. Okay, after this one, there's only one more. Keeping space Oakland with 20 smaller unidentified nodes. So let's put that in here, and we don't need to pass in any second argument because 20 is the default. And that should do it. Okay, so far so good. We've completed this entire section, and now let's do this other last section. Ambitious, AMBTIOUS. That's going to be another main node. So again, we want to have another copy of this entire block, and the name of it is going to be ambitious, and we can rename this variable to be ambitious and replace that here, all of these. And you know what I want to do is just have an empty place to paste into these children. Okay, what are the children of this main node? We've got East Bay Permanent Real Estate Collective. That'll be an awfully long label. I might just use the abbreviation here. Yeah, I'll just put the abbreviation. That has 20 unidentified nodes. Here's another one, Sustainable Economies Law Center. Again, this is long, so I think I'll just use this abbreviation. Paste that in here. And you know what? These don't have any 20 smaller unidentified nodes in this document. I wonder if that was just an oversight, or they don't have a volume of entities. But I'll just assume that was intentional, and assume that, you know, these all should not have any child leaf nodes. So we already have this additional argument to pass in. If we just pass in 0, that should work. And that's the pattern for the rest of these. So I will create this empty vessel to just paste these other labels. The Runway Project. Paste that there. Common Future. Paste that there. Freelancers Union. Paste that there. U.S. Federation of Worker Cooperatives. Paste that there. Get rid of our one dangling placeholder. And if we run this, it works. But this whole thing is disconnected from everything else. I think we just need to make sure that we add the connections between ambitious and all the other main nodes. So how would we do that? We just have connect main nodes from ambitious to everything else. So I'll just copy paste that a bunch of times. And so we've got CAST, we need this other one, Social Impact Commons, and also Arts Web. So now this looks more or less correct, I think. All right. So far so good. I mean, this is looking decent. and it has all of our data in it. So, from here on out, I believe it's just going to be tweaking these various parameters, and then we should definitely do a styling pass. And color too. I mean, maybe we should use color. Let's take a look at the original example. Yeah, the original example uses color, which is related to the data, so maybe we should do that next, focus on that next. But anyway, this is substantial progress for now. With one last push, we should be able to have something presentable that we can deliver. Alright, this is what we've got so far, but it's still a far cry from this example, which we kind of want to shoot for this aesthetic. We have a lot to do, like tweaking the parameters of the force, changing the sizes a little bit, working on the text wrapping, but I think the first thing that would make sense to focus on is the colors. Notice how each set of nodes has colors based on its main node, which we're calling it. And this is related to the data. I mean, we're going to have to come up with these colors in the data generation part of it. So yeah, let's go ahead and try to add the colors. In the code, the colors, well, we can maybe modify this add main node function to generate a color for each main node as it gets added. But first, we're going to need a source of colors. There are all sorts of color palette generators out there. I think somebody once recommended Peloton to me. It looks like a pretty neat tool. But how many main nodes do we have anyway? How many colors do we need? It looks like we have 4 main nodes: Arts Web, Social Impact Commons, Cast, and Ambitious. So we only need 4 colors. That's great because Peloton only gives us a max of 4 main colors, it looks like. And we can drag this stuff around to sort of tweak the aesthetic. So I'm just going to, tweak this stuff until something kind of pops out. I mean, that looks decent. Let's try these 4 colors. I think we can export this. Yeah, this is cool. It's nice that there's light and dark variations. We could try these out. Here's what we get when we generate the text export. So let's take this as our input. And the color definition is a whole other thing. So I think I'll make a new file called colors.js. And then I'll paste all that in here. And I like having all these different shades available because we can pick the shade and tweak it later. So let's get this into a structure that we can use. We're going to want to export const colors equals, I'm thinking it'll be an array of arrays. So it'll be an array. And then I'm going to use my Vim superpowers to essentially crop out the parts that we don't need. And yeah, so I'll just delete that. I'll also delete the rest of this. And now this is pretty close to an array of arrays. We just have some extra new lines, random text. We need to surround these with quotes to make them valid strings. So we can append quotes to the end somehow. But anyway, this will be the first array. This will be the next. This will be the next after that. And this will be the last. We close it out. Let's see if macros work in here. Looks like they do. So I'll end quote, put a comma, go to the next line, and then execute that macro. So we can pretty much automate the editing of this text. And then we can whip it into shape with prettier. Boom! There we go. Beautiful, beautiful colors. And I think I'll just drop a note in here, generated with Peloton. I'll just grab this link, paste it in there. Credit where credit is due. Okay, now that we've got these colors, in our data generation logic, that's where we can use this stuff. In this module, let's import colors from /colors. And what we want to do is associate the color to each of these main nodes. So I'm thinking we introduce another field alongside size called color. And this can be colors at some index that's the main color. And then within each of those entries, there's a sub-array with the different shades. And I think the shade we can use for now is the middle one. So I'll just hard code 2 for that. But the question remains, what is I? I should be incremented each time we call this. So we can say I++ right here, and we can just say let I equal 0 to start with out here. And just to check if this is working, let's do console.log node.color. So what this should do, it's going to start I at 0, and then the first time add main node is called, the value of I is going to be 0. And the way the ++ operator works is that this expression here returns the current value of I. And then after returning that value, then it mutates I to be I + 1. So the overall effect is the first time add main node gets called, this is going to evaluate to colors at index 0. And then it's going to get the mid-range shade from that, and then assign that to be node.color. And then the second time add main node gets called, this expression here will get the second color, meaning I will be 1 at that point. So it's going to get colors at index 1, get the middle shade, and so on. So let's see if this works. If I run this, it appears to have worked because we get these 4 different colors. All right, sweet. All right, now that we know that's working, we can get rid of that debug statement and then leverage node.color when we actually render those nodes as circles. So in index.js, let's find where we're rendering those circles. And then when we set the fill, let's make this a function that takes as input the node and it returns node.color. And if there is no node.color, we can use gray. I like to use the OR operator like this, because if node.color is undefined, it's falsy. It's a false-ish kind of a value that triggers this OR to return the next one. So this means everything except the main nodes should be gray. Let's see if it worked. All right, look at that. It worked. Our main nodes have some color. Fantastic. Okay, this is what we've got so far. I'm looking at just spending, as little time as I can to get something presentable from here, so we can, deliver something. One thing I want to do is make these colors propagate to all the nodes, and then do a stylistic pass and tweak all the parameters of the force layout to get it to look decent. So let's start with looking at these colors. In add main node, we are assigning node.color when we add the main node. So what we can do is when we add a child node, we can just carry over that color from the parent node, which we do have access to. So let's try doing something like this. Parent node.color is what we want to use as child node.color. So we can just say child node.color equals parent node.color, and voila, look at that. The colors have been updated. It would be nice to make the links also have the same color. Right now the black is pretty harsh, and it would be nice and smooth if it was the same color as the nodes. So let's try that. Alright, so in add child node, we're assigning the color of the child node, and we're also adding this link. We can just take parent node.color and assign that to a new property on the links we can call color. So color is parent node.color, then format that with prettier. Now we can access color on each and every link object. So in our rendering logic, we can take advantage of that. Here we're rendering the lines, and we're assigning the stroke to be black. Instead, if we assign the stroke to be a function that takes as input a link and uses link.color, or if there is no link.color, we can use black. This should do it. Alright, look at that. The links are the same color as the nodes. But the links are on top of the text? That's just an ordering issue. I think we can fix that fairly easily. We just need to be sure to add the text after we add the lines. See, right now we're adding the text and then we're adding the lines, but if I just swap the order of this, I'll just cut that text and paste it to be after we add the lines. Okay, that problem is solved now. See, the text is on top. I kind of want to color these black lines that connect the main nodes. Let's do that. Here in connect main nodes, we can just assign a color to these links. And let's just arbitrarily say that we're going to use the source color. Okay, cool. Now they are different colors. At this point, we can start tweaking. One thing that I notice is that the black on this sort of dark color is not that readable. I think we can go up one shade, make it a little bit lighter. And recall that in our colors, we're using the shade at index 2. So if we just change this 2 to 1, we get nice light colors. Okay, that looks better, I think. Another thing that pops out is we're using the default font, which I think is like Times New Roman or something. We can use a slightly nicer font by specifying the font family to be sans serif. Okay, that looks a little better. The problems now are, issues of overlapping text, and the layout is not quite right. Let's see what we can do by tweaking our various parameters. I'm noticing we have this default distance, but what I'm really looking to do with this tweaking is to make the main nodes farther apart from one another, but not impact how far apart the child nodes are from the main nodes. So I think I would like to introduce another constant here, like main node distance, and then use that when we add the connections between the main nodes. Yeah, when we connect main nodes, instead of default distance, this should be main node distance. Now, if I increase main node distance, they should be a little more spread out. One thing I'm noticing is that all of these nodes seem to be bunched up, and I think these are the ones that don't have any anonymous leaf nodes. Maybe we can just add a couple anonymous leaf nodes for those, like maybe 3 for each, just to make them spread out. And I kind of wish that I could just drag these around to position them to, avoid the overlaps. That would actually get us to something presentable. Luckily, there's a module that we can use that does exactly this, D3 drag. Here's how we can use it. Instantiate a new instance of d3.drag. To do this, we can import drag from d3 and then introduce a new variable, which is a new instance of drag. Let's call it drag interaction, just so that we don't conflict with the variable name drag. And here's how we can use it. We can select the nodes and then use .call and pass in our instance of D3 drag. Then we can add some event listeners to handle the actual interactions. In our case, we're calling it drag interaction, and we want it to be on the circles. So right here, we can just say .call and pass in drag interaction. Now, after we construct our drag interaction instance, we can say .on start. So here's drag interaction. We can say .on start. And this can be a function that we define right here. And I'll just say console.log start, just to see if we're here. And now, if I click on this, it works. But what happened the first time is I clicked on the text accidentally. We can solve that issue by adding some CSS to the text to make it not selectable. We can set pointer events to be none. I think that should do it. No, that didn't quite work. Maybe that needs to be style. Okay, that worked. Now I can no longer click on the text. Oh, another thing I notice is that the lines are inside the circle, but they should not be. This is another thing we can fix just by changing the ordering so that the circles come after the lines. Okay, there we go. So let's get back to implementing this drag interaction. It turns out that when we use drag.on, we can pass in start, drag, or end. And what I'm thinking is we can just use drag. This is after every move. And in our drag handler, we just set the XY position. Let's try that. So instead of start, this will be drag. And I believe drag takes as input some arguments. Let me just see what these are. I think there are 2 arguments, and I'm just going to console.log these arguments to see what they are. It appears that the first argument is a drag event, and the second argument is our node object. This is great because we can just set X and Y on our node object. So B is node, A is the event. So what if we just say node.x equals, well, we want to get the X from the event. And I don't quite remember what that looked like. So let's console.log the event and take a look. This is what the drag event looks like. It's got X and Y right here. So we can, in fact, say node.x equals event.x, and also node.y equals event.y. Now we should be able to drag it, and look at that. We can totally drag it around. The problem, though, is that after I release it, I can't drag it around anymore. The whole simulation just freezes. This is where we need to interact with the simulation, because what happens is the simulation cools down and stops when there's no more motion. So we need to essentially restart the simulation, or maybe we need to set alpha target or alpha. I'm not sure exactly what way to do it, but it says this method can be used to reheat the simulation during interaction, such as when dragging a node. So that's perfect for us. So let's try that. We want to call simulation dot something, but I kind of like to define things before we reference them, so I'm just going to move this to be defined after simulation. So let's try it. Simulation dot restart. On each drag, we restart the simulation. It still freezes after dragging, so maybe we need to say simulation dot alpha equals, well, whatever it started out as. Let's see, what is simulation.alpha? Okay, it defaults to 1. So let's try setting it to 1 and then calling simulation.restart every time we drag. All right, this seems to be working. Sweet! So now we can untangle some of the stuff. Oh, wait a minute. Wait a minute. Something is wrong. I don't know why it cooled down and stopped like this. I don't know, maybe we need to use alpha target instead. let's try that. Alpha target. Oh, wait a minute. Maybe this needs to be called as a function. Maybe I just missed that. Let's see. Does this work? Okay, I think this is actually working. Yeah, not bad. But, you know, after I drag it, it sort of gets sucked back into the simulation. What I really want to do is have it just be in a fixed spot after I drag it. It turns out, to fix a node in a given position, you can specify fx and fy. Let's try that. Instead of specifying x and y, let's specify fx and fy. Now, if I drag these things around and let go, it remains fixed to the place where I dragged it. So, let me just, you know, separate out some of these things. This one's going too far. And this is great. This is great. This is really shaping up. Let's bring in that one. It's getting too far away. And, you know, we can make it more of a landscape kind of a thing, so it doesn't go so high vertically. Oh, that one's going too close. There we go. There's our first deliverable. So what I can do now is just take a screenshot of this and send it over and say, look, here's what we've got as a first pass.